Okay, so we are interested in finding the middle 97%. So here's our mean right in the middle. This is of course our normal curve. So right in the middle is our mean of 1263. The middle 97%, so if we know the entire normal curve is 100%, so if the middle is 97%, which will be going from here to here, all of this here in the middle is going to be our 97%, which means you would be left with 3% on the outside, which is going to make up these two tails of our normal distribution. So since there are two equally sized tails, that 3% breaks up into 1.5% here and 1.5% over here. So basically what we are interested in is finding out what these data values are going to be, these numbers, where we form that middle 97%. So let's say we want to find, let's call this guy X1, let's call this guy X2. So we're interested in finding X1. Now for both of these, we're actually going to need to figure out what the probability is, and then based on probability, we'll need to figure out what this data value is. So you are using this formula for your z-scores. Z equals X minus the mean, mu, divided by standard deviation. And this X is going to be our X1 and X2 unknown values that we're trying to find for these part B question over here. So first we have to figure out what these overall percentages are. So, of course, we know in the middle, we are looking at this 97%. But since your normal distribution table always gives you the area, which is going to be to the left side of your z-score, we basically need to figure out what the area for this entire left-hand side of that X1 z-score is going to be. So that will include this little tail of 1.5%, plus it would include this entire center or the middle part of 97%. So if you think about it, this whole red area will add up to 97 plus 1.5, which will come out to be 98.5%. So that's actually our probability. So if we convert that into decimal, it will come out to be 0.985. And if you want to make it 4 decimal places, you can make it as 0.9850. So the first thing we have to do is figure out which z-score is going to correspond to this probability of 9850. So the first thing you're going to do is go to your standard normal distribution table and try to find it. So I'm actually going to start on page 2, and I will see if page 2 can help us out a little bit better. So I'm trying to find either the exact number of 0.9850 in the table or the number nearest to it. So it looks like we can make our table just a little bit bigger. So we're looking for 9850. I'm seeing 9878, 9850 right over there. So that's my 9.9850, which corresponds to 2.1 on this side and 0.07 on this side. So it actually looks like for this guy, our corresponding z-score is going to be 2.1 from that left-hand side. And then the 0.07, that will become my second decimal place. And that will be 2.17 from over here. Okay, so that's kind of how you're going to use this idea of the probability to help you find the z-score. Alrighty, so this guy corresponds to a z-score of 2.17. So that's what I'm actually going to put here, z-score of 2.17. equals x, which is my unknown, and you can call this your x1 from that right-hand side, minus our mean is 1263. And then we're dividing this entire thing by our standard deviation of 117. And you can see these numbers are already given to you right here in the first statement of your problem. So now all you have to do is work backwards to find that x1 value. So, you can start by multiplying both sides by 117. So 2.17 multiplied by 117 will give us, let's see, 253.89. Of course, on the right-hand side, these guys will just cancel each other out. And then we are left with x1 minus 1263. So to get that x by itself, you will add 1263 to both sides. Of course, on the right-hand side, they end up canceling each other out, and you get a data value of x1 as, let's go ahead and add those numbers. And it looks like we are actually getting 151.6.89. So you can see this number was incorrect for your, or actually this was on the right-hand side, sorry. So that should be for this side, the upper limit, this guy over here. Okay. And then in that same way, you are going to find for the x2 value over here. So let's go ahead and take a look at that. So same formula, you're going to use z equals x2 minus mu over sigma, but now we're interested in x2. So this is this number over here on this side. So that means, as far as the area goes, you're just interested in this left-hand side of the tail, which has an area of, 1.5%. So as a decimal, this guy will become 0.001050 if you just round it up to 4 decimal places. So same thing like you did with the right-hand side, you will find 0.0150 on the table and then try to figure out what z-score it corresponds to. So this number being so small, I'm actually going to go to page 1 of our table and see what I can find. 0.0150. Okay, so I am looking at so I know it might be a little bit harder to see, but I'm looking for 0.0150, and I actually can find it right over here. 0.0150, and you can see this guy corresponds to a z-score of -2.1, and my second decimal is 0.07. So it should be no surprise that you ended up getting the negative z-score of the number, the z-score you got on the right-hand side because of that symmetry. Remember, with standard normal distribution, the left-hand side from the mean and the right-hand side from the mean are symmetric in a normal curve. So you can see we were just able to verify that you will get the negative z-score that you got from the positive side. So -2.17 is going to be our z-score. So I'm going to go ahead and close this guy and perhaps get rid of some of these markers over here. Alrighty, so let's go ahead and write that down. So this z-score came out to be -2.17. So that's if honestly, if you find one side, you can just make that negative to get the other side. But remember, this only happens when you have the same area on the left-hand side and the right-hand side. So your z-score is now going to be negative 2.17. X2 is unknown, minus mu. Sorry, we should probably put numbers in there. Okay, so our mean is 1263. Standard deviation is 117. So just like we did on this side, multiply both sides by 117. So this guy will end up becoming negative 253.89 equals x2 minus 1263. You know, of course, the 117 will cancel out from that side, and then just add the 1263 to both sides. But this time, since you have a negative 253.89, you know, of course, you will end up getting a smaller number on this side. So those guys will cancel out, and let's see what happens when we solve the left-hand side. You end up getting 1009.11 as this score. So this guy will be this side. So looks like your calculations were just a little bit off. So, you know, just go back, redo the calculations, and I think this should help you out. Okay. Alrighty.